This is Radio Ecoshock with your host, Alex Smith.
Climate truth is breaking into the mainstream. Like this headline from USA Today, "End of civilization, climate change apocalypse could start by 2050 if we don't act." Sure, it's just one blip buried in celebrity news and the Donald Trump show, but still, maybe soon they will hear about Radio Ecoshock and Paul Beckwith. Paul is a regular correspondent here. He is the Canadian climate scientist who set out to educate the world via YouTube. As recent extreme weather reveals the nasty side of climate change, it's time to get Paul's assessment. Paul, welcome back to Radio Ecoshock.
Hello, Alex. It's great to be with you.
Hey, Paul, when I saw you writing humanity's tombstone inscription in a YouTube video title, I thought, maybe I better check in with Paul. Are you doing okay?
Yes, personally, I'm doing great. You know, it's nice to finally get some warm weather. We've had a very, very cold spring in Ottawa, like many places, and lots of rain. Finally, it's going to be 26, 27 on the weekend. Don't tell that to people in India, though, right, who are suffering, the whole country suffering over 50 degrees Celsius temperatures.
Yeah, well, we'll get more into that as we get going here. You have lots of company now, Paul, as big papers like the New York Times, USA Today, and The Guardian in the UK are starting to report on the developing climate disaster. But behind that news, Mark Kaufman at Mashable jolted me with some basics. It's not just that we're adding billions of tons of greenhouse gases to the atmosphere again this year. We are doing it faster, and he writes, quote, "After the Scripps monitoring station atop Hawaii's towering Mauna Loa went online in 1959, CO2 rose around just 0.7 parts per million per year in the early decades of operation. Then in the 1990s, the rate increased to 1.5 parts per million per year. The last decade has averaged 2.2 parts per million. Yet in the last year, 2018, it was 3.5 parts per million gain. Concentrations of the planet's most influential greenhouse gas are accelerating," end quote from Mark Kaufman. So to me, Paul, that's the scariest news of all. We are literally hitting the gas pedal as we drive off the cliff. Isn't that what is behind everything else we talk about?
Yes, that Keeling curve showing the CO2 fluctuation, it's recorded each day, so day to day or even, hourly, but that's really the curve that is behind everything. I mean, those levels have been accelerating at ever faster rates. We have many years now that are over the 3 parts per million gain per year. As you said, 3.5 sets a record. And yeah, we have to bend that curve over. We have to get CO2 levels in the atmosphere back down to stable levels. And some people have said 350. That started the organization 350.org. And, many people, including the Healthy Climate Alliance, are arguing that to stabilize climate, we need to get about the 300 level. That needs to be the target. So the big question is, how do we do that? Are we even capable of doing that? And it's not just CO2, it's, methane is on a tear as well. We're setting new records, and also nitrous oxide is accelerating upwards too. All of these greenhouse gases that are key, they're accelerating upward. They're not just rising at constant rates even.
You, Paul Beckwith, are really kind of a pioneer in the science of abrupt climate change. I know you considered doing a PhD thesis just on that, but you got swept away by the torrent of evidence and science. Is an abrupt climate shift already underway?
Yes, it is. It's well underway. Think of it as, we generally had a stable climate before with a linear rise in all of the parameters of climate, whether it be surface temperatures, ocean temperatures, CO2 levels, disruption to weather patterns, etc. It was sort of, a linear increase, and then the Intergovernmental Panel on Climate Change would make projections saying, well, it's going to stay linear. But clearly, we've notched up. The slope of the curve has gone almost vertical, and we're rapidly accelerating to a much warmer world. And eventually, we'll reach this state. The final state that we're heading for is one without snow and ice in the Arctic, completely open Arctic Ocean year-round, sea level rise still notching up rapidly because the melt from Greenland, which will be the only ice-covered region left in the Arctic soon. There'll be no more sea ice, will be exposed. And so we're heading up to this much, much warmer planet. Of course, with no ice covering the Arctic Ocean, the jet streams will be completely rewired, configured to something different, be much weaker. And we're going to be in a more monsoonal world where weather patterns on continents everywhere, including in the Arctic, are affected more by the land-ocean contrast that will occur. So there's no new normal. I mean, people say the new normal. The CBC was asking me about the tornado that hit Ottawa recently, and, is this going to be a new normal, more tornadoes? And I said, I really emphasize that there's no new normal. We're undergoing abrupt climate change. We're going to see huge, rapid changes. We've only basically seen the tip of the iceberg, so to speak. We haven't seen anything yet. Extreme weather events are greatly increasing in frequency, severity, and duration, and they're happening in locations that we don't expect. I mean, the torrential rains around the world are just phenomenal. I mean, it's a different place every day. There's some new catastrophe around the world as a result of these extreme weather events.
Let's slide a little bit into your new 6-part video series on abrupt climate change. And one aspect that I've been stewing about is what seems to me the inevitable clash between climate-driven weather extremes and our need for more and more human food on this planet. What are you seeing?
For quite a while, I've been saying we're in a climate emergency. And the reason I've been saying that is because there's a huge threat to our global food supply. Up to now, we've had events in various countries. For example, in 2010, the heat wave in Russia basically ruined 40% of their grain crop. They had to import that year. Arab Spring happened as a result of shortages. Australia is, under huge drought, and their wheat growing areas are being pushed off the continent. This year, they had to actually import wheat grains from Canada because their crop basically failed. Of course, the U.S. with the trough stuck over over North America this last winter, making it very cold, but with lots of snow. A trough is a low-pressure area, stormy, so lots of snow, huge snowpacks on the ground, and of course it melted, saturating the ground, and now the troughs have continued, and we've had this torrential rain situation, massive flooding, of course, record levels of rivers. So this has affected crops in a number of ways. The first thing is, because of the Trump tariffs, they were storing a lot of soy and other things. And, when the grain elevators got flooded, the soy would absorb the water, just expand and explode out the grain elevators. So they lost about 30% of the crops that they were storing, and they stored record amounts because of the tariffs. So the next thing is that the crops that were already planted in the winter were in the ground, and they basically were rotting in the ground. There was very little yield from those crops, from the winter planted crops. And of course, they haven't been able to plant. Planting has been delayed because the ground is just too wet. I mean, maybe they should be thinking about planting rice in those flooded fields, right? But anyway, so the planting hasn't happened. And if that continues, there's definitely going to be food shortages, global food shortages, I think, because Europe is also under very cold conditions, a sharp trough coming down there, lots of rain. So their crops are horrible as well. And China has a blight. There's a pest that is affecting their crop yields. It's not clear how serious that blight will be. If it's very serious and if planting continues to be delayed in the U.S., then we're looking at global food shortages. In Canada, we're a food-producing nation for the world, and there's some areas in our plains that are under drought, and yields are very, very bad. And in fact, because of this trough, I think it actually snowed a few days ago in Saskatchewan in some places. So all around, it's not looking good for food supply for the world.
Meanwhile, we're getting smoke in our skies from the great fires in northern Alberta, and it's always ironic that these fires are happening around an oil-producing, the tar sands area. But those are massive fires, and the smoke is covering a big area, and that also changes the way plants grow and agriculture in other areas.
Yes, the fires and the resulting smoke can actually block out quite a bit of the sunlight on regions where the smoke is, and it can cause a cooling at the surface. I mean, the smoke particles are just like the aerosols that are responsible for the global dimming. And a while back, I did a series of videos on this new phenomena where the fires are burning so strongly, they're so hot, and there's a huge convective uplift from the fires, and it can create and generate these massive clouds that look very similar to cumulonimbus thunderstorm clouds. They're called, basically pyrocumulonimbus clouds. So fire is creating the weather, and then the problem is these type of storm systems are a bit different. There's more chance that they're not going to be producing water, actually, but they'll produce the lightning. So you get lightning, and that's setting fires a long distance away from the original fire. And we're also getting phenomena like firenadoes, where the convective uplift from the fires are so hot that the airflow upwards from them, hot air rises. The hotter it is, the faster it'll rise, and it's getting this rotation and getting these firenadoes, and then they're tossing burning embers up to 5 kilometers away from the initial fire, and stuff is even carried higher and then dropped miles away. So I think after the Fort McMurray fire a few years back, there were fires started about 22 miles away. A fire ignited, and it was, some burning embers that went up and came down and ignited the fire, or it was lightning from the huge pyrocumulonimbus cloud that ignited the fire. So this is a huge problem. Firefighters are having difficulty knowing how to fight these fires. In fact, I posted a video of a fire truck, basically, with one of the huge hoses, and the hose was actually sucked up into one of these firenadoes, and the firemen are all trying to pull it back down. It's like they're flying a kite or something. It's just crazy stuff happening.
This is the stuff of disaster movies, and you'd think Hollywood wrote the script, but we've just not seen things like this on Earth before during human times. And then we have the inevitable pressure of longer and harsher heat waves building in future years. And as you pointed out, it's not that far off. Just last week, northern India went over 50 degrees C. That's 122 degrees Fahrenheit. They were pouring water on the roads, trying to keep them from melting. Farm animals and people keeled over dead. And yet hardly anyone in Europe or North America even heard about it. But the big heat is not that far off, is it?
No, it's not. And, of course, the India situation is, with those high temperatures, at least the humidity. The monsoon is late in India. The monsoon should be coming, and that should cool things off a bit, but it hasn't arrived there yet. And, one of the problems is when you do get, lots of humidity in the air, you just need 35 degrees Celsius and 100% humidity. And basically, you're not able to sweat. You can't, you'll die outside in about, 6 to 8 hours, basically, even sitting in the shade outside. The body just can't reject heat. So there's some interesting products that I think will become very popular soon. And that's, I call it the chill suit, where you actually wear some clothing which circulates a liquid, or it has thermoelectric coolers, and it can cool your body directly, be battery powered in the case of the thermoelectric cooler, and, allow you to be outside and to have your body cool. And MIT is just working on this device. Also, there was a report about it recently about cooling the body. I mean, think of it. I mean, we cool an entire room with air conditioning. If we can, have a suit or something, call it a chill suit, where people can individually cool their bodies, that would be a lot cheaper energy-wise than cooling an entire room for people.
Oh, my God. Little Billy, don't go outside without your chill suit. You might die. Okay, so, it's terrible.
Yeah, and then we'll add, an oxygen mask soon to it, too, plus a particle filter, right? I mean, breathing all that smoke is horrible. In fact, people... I've heard of people in, Western Canada that are sealing an individual room, and putting filter systems so that, when there is a wildfire and their whole town is engulfed in smoke, they can go into this room and breathe fresh, purified air.
Oh, I've already been there twice, right here where I live. I've got HEPA filters, and the house is totally sealed off. You don't open a door or window. It's unreal. Now, The Guardian newspaper and the New York Times also just covered new science about thousands of heat deaths expected in cities like New York and Los Angeles every year by 2050 if the climate heats up by 3 degrees C. Is that possible? Could we see thousands of people dying even in North America and Europe?
We've already had glimpses of that in, of course, the European heat wave. In 2003, I believe it was, there were something like 70,000 people died. Now, it was mostly older people who, air conditioning was very rare in a lot of those places, and people were just overcome by the heat. But there's been some similar intensity heat waves since then, and the fatality rate is much lower because there's cooling centers, there's community centers where older people know to go and to stay hydrated and so on. In Montreal, in Quebec, province of Quebec, in Montreal, just in last summer's heat waves, there was, about 70 people reported to have been, died in the heat wave. Again, it's older people and younger people who, very young kids. They basically don't have the ability to sweat, so when they have a temper tantrum, their head turns completely red, their face completely red. And when they get too hot, overheated, the same thing happens. They can't reject the heat, so they're much more vulnerable to these heat waves, as are the older people. Just can't deal with it. So I think the only reason the numbers weren't reported in cities like Toronto and Ottawa for heat deaths, last summer is because the records are just too poor. I think those heat deaths probably occurred, but they're not. The public records for those heat deaths is far better and almost real time in Quebec. So we're already seeing this, and we're pushing the margins of what the human body can stand. So, people that have any underlying medical condition or are weaker to begin with, as you get older, your body's not as resilient. Those people are most at risk.
Check out the Radio Ecoshock website. We're at ecoshock.org.
This is Radio Ecoshock. I'm your host, Alex Smith. With me is Canadian scientist Paul Beckwith from paulbeckwith.net, and we are talking about the signs of abrupt climate change upon us. Our other guest this week, Paul, is meteorologist Richard Rood. Right during my interview with him, a new article by Richard popped up on the online site The Conversation. He was writing about the Great Lakes in North America, which do hold 1/5 of all the fresh water in the world, and those lakes are going haywire in unexpected ways. Did you read that article by Richard, and what is your takeaway?
Yes, I did. I mean, the interesting thing about the Great Lakes is most of the water is, you can trace it back to the melting of the glaciers that covered North America. Of course, just a few years ago, when we had some of these persistent heat waves, the lakes were at record low levels. There just wasn't enough inflow into the lake, and the water temperature was higher than normal, so there was higher evaporation rates, so the lakes were all setting record low levels. People were very worried that lived along the shorelines, and their property prices would plummet, and, their docks and things were high and dry, and the smell of the algae on the shorelines was horrible. It was a detriment to live along the lake. And then, of course, in the last few years, we've had record high levels, and there's lots of flooding along the shorelines. One of them, most notably, was the Toronto Island. The people living on Toronto Island had to sandbag like crazy, and there was record flooding there. And right now, the lake's almost 2/3 of a meter higher than it was in the previous record. So, we're breaking records year in, year out. And same thing with the rivers feeding in. Of course, Ottawa, in the last 2 years ago, we had the flooding. And then September 21st of last year, we had the swarm of tornadoes. And then this year, we've had the record flooding surpassing that of 2 years ago, and we've had our tornado, just on the weekend. So no city is unscathed. Of course, the Great Lakes are an enormous supply of water to millions upon millions of people, and they're also cooling nuclear plants that are on the shoreline. So as water temperature rises and as the lake level fluctuates, it can be very problematic to this power generation.
Well, I think this is further proof of what you said earlier, that as soon as a bad pattern seems to set in, we think, Oh my God, is this the new normal now under climate change? But there isn't a new normal, and that's the story.
Yeah, there isn't. If you're on a trajectory that's pretty flat or slightly rising, you can sort of, know what to expect. But if you're on a trajectory which suddenly becomes a vertical line, you don't have to move very far in the X direction to have a massive change, and we're on this line or curve almost vertically going upwards, and so all bets are off, until we end up at an area that's a bit more stable, and that area or region, the stability that we're heading to is a much warmer planet with really bizarre, weak, fractured jet streams and, much more monsoonal torrential rain patterns on the land. I mean, we're already seeing it.
Well, we can't talk about extreme weather without covering the 45 days of constant storms, weird ones, running from Texas to the Northeast. It was floods, hail, tornadoes, the works. How was that climate related, though?
Yes, well, it's got climate written all over it. So what happens is some of the big factors that affect the location of these storms and their severity is, the first factor is the Gulf of Mexico. The Gulf of Mexico is very, very warm water, much warmer than usual. So there's lots of evaporation, and the winds carry this moisture-laden water from, hot, loaded with water vapor, and it carries it up northward, up into, the southern U.S. But this beats the second factor, which is the very hot, dry air coming down from the Rockies. It undergoes adiabatic expansion as it comes down. Doesn't have moisture in it, so you get very, very hot, dry winds that are moving from across the desert, and they basically meet this Gulf of Mexico humid air in what we call the dry line. And this dry line can run almost a north-south line where the air meets, because the air doesn't want to mix. It takes energy to... So as the air comes towards each other from both regions, it starts moving northward, and it creates this dry line. Now, what we had this year is the jet stream being so far south in this trough is the third factor. So it's bringing very cold air, also dry, downwards. And where these three things intersect, watch out. There's incredible amounts of energy, or we call it CAPE, convective available potential energy. So because of the temperature difference and the moisture difference and stuff, we get this clash of all, huge temperature differences, huge humidity differences, and all the factors are there. The jet stream is moving very fast, can cause the shear, so the wind is moving faster as you go higher up, and it spins up all of these mesoscale convective complexes, or massive storms, but combines these massive cumulonimbus clouds into massive trains of storms. And then as the jet stream moves and the storms move and spin up, they're just throwing off tornadoes left, right, and center. Yeah, this is basically what's been happening. And over time, with climate change, I think I've already pointed out in some previous shows, and certainly in a number of videos, how basically Tornado Alley seems to have been shifting to the east and also northward. So, if you look at the spread of these storms, almost 1,000 tornadoes in the last few months, you can see that they're spread very far eastward. They're not concentrated just in Tornado Alley. They're spread across lots of the U.S. And we don't have we've got very good warning systems in Tornado Alley when a tornado's coming, but systems are much worse, much slower, and not needed as you move eastward. So people aren't ready for them. They haven't seen these things, and by the end of the summer, of course, they were coming up into Canada last year. And already, we've been seeing, tornadoes in Ottawa, June 2nd. This is unheard of. So everything is shifting, like all bets are off. But it's not a new normal. Like, continue to undergo abrupt change, it could get a lot worse, the tornadoes, or they could shift location, or, maybe some conditions are such that they become very quiet again or something. There's no new normal. There's whiplashing from, torrential rains and flooding one year to drought another year, back again. There's no new normal, and it's kind of, you'll notice most meteorologists are going bald. They're pulling out their hair because their forecasts are terrible, because the system has changed, so their analogs of what they expect to happen becomes much harder to predict for them.
Well, we've only got a couple of minutes left here together, so I know one of your specialties is the Arctic. If you'd like to talk about that, please go ahead.
Yeah. The melting in the Arctic it's very concerning this season because, the ice is so thin and fractured and broken up, and it's on the move. If you look at some of the satellite images, if you go to Google Arctic sea ice graphs, and look at all of the real-time data, it almost looks like the whole ice sheet in the Arctic is pulling away from shorelines towards the, north of Alaska, in the Barents Sea area. And, it looks like the whole thing is on the move. And there's huge export of ice this year, broken, fractured ice, both through the Fram Strait between Greenland and Svalbard, down to Iceland. There's huge infiltration of ice through the Nares Strait and into the Canadian archipelago islands because the ice, there's no ridging there. The ice is thin throughout. I think we're heading, all the ingredients are there. The temperatures are much higher than normal in the atmosphere, and the wind pattern and such are conducive to a year where we have record melt. So it seems pretty clear, unless something changes, that we're going to greatly exceed the minimum sea ice year of 2012. One of these years, we're just going to see the ice here today, gone tomorrow. We're just going to see the whole basin cleared out with resulting in great increase in warming. No ice in the Arctic Ocean, and the warming just skyrockets because you lose that latent heat effect, which keeps the temperatures about zero where the ice is melting, or the freezing point where both water temperatures and air temperatures above. So everything's changing. The ice is going to be swept out of the Arctic and be completely gone come 1 September, and with very likely within the next 4 or 5 years. That's what the trends are all pointing at anyway.
And when your freezer breaks down, you got to throw all the food out because everything melts. So that's no good. From Ottawa, Canada, we've been speaking with our in-house climate scientist, Paul Beckwith. Paul takes you through every step to understand the latest climate science and current extreme weather in his videos. So be sure and visit his fabulous YouTube channel. I also really like his website, paulbeckwith.net. I check in there pretty regularly, and he's got a busy Twitter feed. And you should also hit that button to support his work. Thanks again, Paul. And as we often do, I hope to get your summer report when we kick off a new season next September.
Okay, well, thank you. So I have to run off to my 3-hour oceanography lecture. I'm teaching at University of Ottawa.
For Radio Ecoshock, I'm Alex Smith.
Check out the Radio Ecoshock website. We're at ecoshock.org.